Okay, so what I'd like to cover today is the history of our company and what the issues that we faced, what we're doing about it, how we monitor the systems, some of the tools that we use. We use rSyslog, Voip Monitor, Cacti and Nagios, and we have a 24/7 NOC. It's a lot cheaper than you would think it is, what it costs. There's a lot of solutions. We have companies overseas that could do it at a very good price, and they get stuff done. All right, so our history. The company started in late 2006. We started out with 2 servers and 1 data center. Obviously very small, 1 Asterisk box, 1 SIR box. We slowly grew the company over about 9 years from 2 servers and 1 small data center to 100 different pieces of hardware across 5 data centers in 3 continents. Now I say hardware and not necessarily servers because we started with 2 servers, just IP tables, a very basic setup, and slowly built up to where we have our own routers, our own IPs, our own network, and grew from there. Everything was working fine, so we didn't think we needed a monitoring system. No one ever told us. We were fairly new. So everything was running until one day we had a problem where we went down, we didn't know why, and it took a couple of hours. So it took us time to figure out what went wrong, and then we had to find a solution to make sure that this didn't happen again, that we didn't have downtime because of ignorance. Having an unmonitored network is like shooting blindfold. If you're letting your network run, it's just it's Russian roulette. It's a matter of time before you're going to have a problem, whether it be somebody hacking you, whether it be resources eaten up, or something as simple as the disk filling up on the server and you not knowing about it because you're not watching it, and then your server goes down and there goes all your services. So monitor, monitor, monitor. You should always be watching your network, always know what's going on your network. If something doesn't look right, you should be investigating. It could be as simple as, you know, your standard of normally having, cover this in a bit, your server having 250 concurrent calls, even if the box can handle 1,000, but if that's what your load normally is, and all of a sudden you get an alert because 250 is your standard, so your alert is at 300, and you start seeing 300 calls, it could be somebody got compromised. It could be somebody's using a bulk dialer, and if that's the case, your suppliers are going to hate you. But you want to look into it, and you should be checking it anyways. You should be doing reviews of your system at least once a month. You want to look over everything. You want to see that there's nothing wrong. You just want to look over everything. You don't want to wait for a problem to then have to go ahead and start investigating it. You want to be proactive and possibly anticipate when problems will happen so you could fix them before your customers find out. My whole goal in the company and everything that I do is to try to see if I could find problems before they happen, try to set up as many alerts as possible, and we'll go over that in a bit, but you want to see if you could find potential issues before they happen so you know about it and your alerting system is not your customers calling you up saying, hey, the service is down. So the first thing that we use is rSyslog. If you just have 1 Asterisk box, it's fairly simple. We use the full log in Asterisk in etclogger.com. We enable full. If you don't watch it, it will fill up that server, so you have to be wary of it. You have to configure rSyslog to rotate those logs. I remember the first system I built about 12 years ago. Was fairly new to Linux. I set up the box, everything was working fine. 3 months later, customer called that the PBX wasn't working, and it turns out that the full log jammed up the box and the disk was full and they couldn't make any calls. So you want to make sure that your logs don't take over your machine. If you have multiple servers like we have, we found it simpler to have all the servers. If you're trying to trace a problem, instead of logging up and SSHing into 4 or 5 different servers and grepping out from the log files the phone number or the problem, whatever you think you're looking for, you have everything using rSyslog going over to 1 server. So when you're trying to troubleshoot, you're trying to look at your logs, you have 1 central place where everybody could go to look. Besides for Voip Monitor, which I'll discuss in a bit, that we use this a lot whenever a customer complains. The first thing we do is go through the logs, see if we can find their call, see if we can find what their issue is. There are also hosted options if you want to use paper trail, log entries. Like I said, we use it locally because it just makes more sense for us. Because we're not located in the cloud, we're located in a data center. It makes it easier for us to have the rSyslog server locally. One more note, you want to use at least rSyslog 8. We found that versions previous to rSyslog 8, we had problems where the queue would get too full, and then the server couldn't keep up with it, and then we were trying to trace calls real time, where we would be doing, I'll show in a bit, using the tail command, and then somebody would go ahead and somebody would make a phone call and it wouldn't show up in the logs till a few minutes later, and it became unbearable. And after tweaking the settings plus using rSyslog 8, everything started working. So on the Asterisk server, it's very simple. In etc**logger.conf, we have sort of what we would have for full, except we're sending it to local 0, which is sending it to rSyslog. In rSyslog, we have set up local 0 to connect to 2 different servers for redundancy, to send the logs to the rSyslog server. And I just put an example that'll work. If you had a hosted provider, you'd have to put in what they would say. If you have one then that means it's going to be sent over UDP. If you have 2, it would be sent over TCP, which I initially thought would be good. If there's any communications issue, however, we found that Asterisk would completely lock up. So if there's any problem with the packets getting over, if there's a problem with an rSyslog box that's just logging in case you have a problem, you don't want to lock up your system. So for us, we found that sending it by UDP was the most reliable way to get the logs there and keep the Asterisk boxes happy. On the rSyslog box, you simply set up that if it's from your Asterisk boxes, if the logs are coming from that specific IP, to go ahead, we dump it into varlog asterisk all asterisk.log, and then if we ever have a problem, we could SSH into the box, do a tail, cat, whatever we have to do on the file, find the relevant call that we're looking for, look through the call, and see what the problem is. Okay, so here's an example of a system that I built for a customer where they were using voice blasting. It was for a school, and they would call into a phone number, they would record their message, and once they recorded their message, the system would then go ahead, dial all the parents, and let them know. So the complaint I got was from a sales guy that they went ahead, they called into the system, and they didn't hear anything, and then all of a sudden they didn't hear anything, and all of a sudden they heard a beep. So obviously the system was trying to play the message, but it couldn't play the message. Now, the only information that I have is the incoming number. So when I start trying to log it, I obviously switch the number for privacy purposes. So say they called 1-800-555-1212. I apologize, I don't have a pointer. If you look at the second to last line, it's going to context voice blast main, priority, extension S, priority 1. So that's all the information you have. Now if you see I have highlighted in red over there the thread ID, which is 26791. Every single time you have a call in Asterisk, you'll have this little number sort of identifying not necessarily this call, but this bit of the call coming in to the system, and if you grep based on that, you should see the entire call. So we did a tail on the file. We obviously escaped the braces that grep shouldn't think we're doing some kind of regex string, and after losing my screen, there we go. So after doing that, we then go ahead and we see, if you can look, you see the 26791 all across. So now we have the entire call. We have the call coming in. We have it setting some, I'm setting some timeouts, and then we go to the bottom, and we can see over there it says enter phone number I have an extra R, it was a typo, and Asterisk is telling us that it can't find that file. So we simply go ahead, we just correct the typo over there, make sure the file does really exist, and then we call back, it is working. Here's another example of our production system where we have many, many calls. Who could tell me what's wrong with this line? Nope. I apologize, it's small. It looked really big.
It's starting at 10.
No, I just took one line. So this is a bit old. The call comes in and to a line above it. If the call was not answered, if the call equals no answer, then it goes to priority 10. Well, what priority is the call? It's going back at itself. Okay. So what happens when you do that? You loop 5.2 million times until you crash your box. And you don't know what went wrong until you bring it back up and go over the logs. So this is why rSyslog was very good. When the box went down initially, we looked in Cacti, we started going through everything, and the only thing we saw was that the CPU jumped, and I'll show you in a bit. We're logging CPU usage for not only the entire box, but it's also very, very important to log every process you have running in the box. If you have MySQL, Apache, Asterisk, OpenSIPs, Camillio, or anything else that you're running, you want to monitor the CPU usage on every single process. So if the box does crash, you know what caused it, because you want to be able to fix it. You don't want to be just, you know, no offense to Windows users, but be a Windows user and reboot and take care of your problem. You want to make sure it doesn't come back. So yeah, that was my fault. That was simply human error. As I mentioned in the full log, and that's what we have enabled in rSyslog, you have a lot of information. Asterisk will output as much as you ask from it. So if you set the full log to, we set general full log at verbose 3, we don't want to fill it up too fast. We do, I would say, between all our boxes, about 6 gigs of logs a day. When we need to enable AGI debugging, but in general we don't, because we don't want to fill the boxes. We went to an engineer that by accident left AGI and SIP debugging on, and in a matter of a few hours the box was almost full. We got an alert and we cleaned it up. So what this script does is it actively monitors the full log. Now this script I'll show you in a bit. You want it to be running on the Asterisk box, not on the rSyslog box. What it does is it looks for a regex stream peer, and then anything else is now unreachable in the log file. You can substitute this for anything else that you would be looking for. In our case, what we're dealing with, and our users connect to OpenSIPs, and we're using Asterisk to send the calls out to the providers. So in our case, a peer is always a provider. If a peer becomes unreachable, obviously we will fail over and we will go to the next carrier, but we want to know that they went down because we want to be able to fix it. So as soon as this little bash script sees that a peer became unreachable, it uses a tool called MTR, which is traceroute on steroids. We tell it to run a report, to only run it 5 cycles, and to email us a trace, and to let us know that the peer is having a problem. And you can see it connects to the Asterisk CLI, and it sees what the IP address of the peer is. It takes the second field. Asterisk will output the peer name, the IP if there's NAT, and the port being used. So all we care about is the second field, which is the IP address, so we can run MTR against it. Make sure you're using the latest version of MTR in Red Hat 6, CentOS 6, etc. The default MTR version is version 0.75. And if you run a report mode, it will, if the ping time is over for the last hop is over 100 to 150 milliseconds, it'll show the last hop with the last 2 hops with 20% packet loss. We had a customer that did this every single time they thought we had a problem and kept on sending a report saying you have packet loss, you have packet loss. There was no issue on our end, and after digging around we saw that MTR had a bug that was fixed. So I believe it's at least version 0.81 that you want to have installed. So this will actually email us, and it only emails us once the peer becomes reachable. Obviously you could adapt this to anything else that you're looking for. We've done this where we had problems where we used up all the RTP ports in Asterisk. We were using a very limited range, and we got alerts about that. We use this for other systems like OpenSIPs. If the memory usage, if it starts complaining, we have to defrag the memory. So you can really adapt this and use this for almost anything. Another script that we have that uses rSyslog checks once every single minute for any peer that became unreachable. So if we were using both of these scripts, the first script would let us know. We don't want to run it every single minute. I have one client that was having problems and CC'd me on all his emails. And when he had internet issues, for 2 hours, every single minute I was getting an email, and I just started rejecting all his emails. So what this script does is it goes ahead and logs into Verilog traces / the peer name. So let's get Verizon / the date, the hour, and then in the minute, it would go ahead and put the MTR trace. So if you had a problem, you want to know, if I can get to Verizon, why can't I get to them? Is Verizon down? Do I have a ISP in the middle that's having a problem? What is my issue? And it's very easily able to go ahead and look on the local box at the trace and see what the problem was. Because our whole goal is that if there is a problem, we don't want to be able to have to then go ahead and try to figure out what went wrong. We don't want to play guessing games, 101 questions. We want to be able to look at the trace and say, not my problem, your problem. That always makes life easy. So what does a bad trace look like? So here's an MTR trace to an IP that is over a VPN, over a cellular VPN tunnel. As you can see, you have problem number one is that we have 5.6% packet loss. That's already going to drop a lot of packets. That's going to make it unbearable. The second issue that you have, even if you don't have packet loss, is the jitter. We have clients a lot of times that tell us, but I have a 100 megabit pipe over fiber, I have a beautiful internet connection, I shouldn't have any voice quality issues. And what they're discounting is how their ISP is taking all their connectivity, jamming it up into a gig pipe, and they have 100 customers, each one giving them 100 megs, and that technically is 10 gigs, but they're just relying on, hopefully they won't be jamming up their pipe, and if they are, oh well, there's going to be jitter, there's going to be problems with the quality. Well, that more packet loss, but if they don't have a problem with the fabric and there's jitter or there's a problem, oh well, it's not going to hurt anybody. It'll take somebody an extra minute for their page to load, but when it comes to voice calls, it's very sensitive. You can see over here, the last hop, the max ping time was 4 seconds. So it's like me saying hello, and then you hearing it, which will make it unbearable. One more note, if you look at hop 7, hop 7, you'll see that that router took 2,600 milliseconds. That only indicates a problem if every single hop thereafter has a problem. If we look at hop number 8, we see it's responding in 300 milliseconds. So that specific router is not responding fast enough, but the other ones are. So the only time we care about routers in the middle acting up is if that router acts up and then every router afterwards acts up, so then we know we have a problem. If I even had a penny for every time a customer sent me a trace and said, but that router in the middle has a problem, I'd be a very rich man. Voip Monitor. So this is probably the single most widely used tool in our organization. I don't know how I lived without it beforehand. It's the best thing since Swiss cheese. Single most used tool in our company. The sniffer is, there's two components to it. There's a sniffer that sits, either it could sit on your Asterisk box, or in our case, where we're running proxies and we want all the calls to show up as one, we run it on a box that's connected to a Juniper switch, and the switch takes all the traffic and it mirrors it and sends it to one specific port, and then this box will go ahead and analyze all the calls. As you'll see in a minute, the possibilities here are endless as far as what information we could get from it. I spoke to the engineers a few days ago. The largest deployment is 2.5 gigabits of traffic, and that's voice and RTP, 15,000 simultaneous calls. And then they have another installation where they have 120,000 simultaneous calls where it's just logging just the SIP packets, and they have roughly 6,000 calls per second. So the two examples I'm going to have over here are registration failures, where there's registration failures on the network, and what a CDR and Voip Monitor looks like, what information you could get. So I put only the basic information, so I have two calls over here, two registration attempts over here. Let's look at the first one. We'll skip the counter for now. Created on October 8th at 1447. You have the source IP, destination IP, that's the proxy, the username, the contact domain, and the kind of phone that's being used. The user agent's important. If you have SIP vicious or friendly dialer or anything like that, if you're not using a proxy and dropping it there, you may want to go ahead and write a script that'll look for any of our friends trying to connect us, and write a Perl script, PHP script to connect to your router and block it. I believe there was a demonstration last year of how to use fail to ban to then connect them to a Cisco and ban IPs. And then I have a second example that was later on, that was actually earlier on at 1:41 in the morning for a Polycom phone that the counter there is 5. So the counter is from when the record was created, how many times this phone failed. So if we have 5 failures, probably means over the last day there was some kind of problem with the internet and had an issue, not such a big deal, but something we may want to look at it. On the other hand, if you have a phone that tried to connect almost 1 million times in 24 hours, I was working on this on the 9th, either the phone is no longer on the system, it's trying to register, but we disabled the user for whatever reason, or it's a hacker, or it could be anything else. But something like this, we would want to have a script that would alert us, that would let us know that there's a problem and investigate it. Now, once we're done investigating either if we fix the phone, or if it's a hacker, we ban the IP, or whatever we do, what we would want to do is we want to remove the record so it's not in there and we keep getting alerted from it. We've made that mistake. So this is very, very condensed. Actually, even after I cut it down, I had to cut it down even more. I even chopped off the word Voip Monitor because there was only so much that I was able to get onto the screen. too small for my laptop. So we have over here, we have the call date, we have the call end, the connect duration, the time the call was connected, the entire time of the call, the progress time, and the first RTP. First RTP is letting us know when the first bit of RTP came through. This is a measurement to measure post-dial delay. So if I'm sending a call to a carrier and it takes, actually, no, this is one that's but more for audio, but there also monitors. I don't think I have the field up here for post-dial delay. The caller domain, which was 1,000. The caller, oops, I'm not reading it properly. The IP address, the caller reverse, I'll go over that in a bit. My name, the phone number that I'm calling, the number that I'm calling in reverse, my IP address of the phone sending the call, the port that it's coming from, the port that it's going to. That's important if you're using alternate ports, which we do to get around for certain customers where we have their ISPs that are blocking SIP because, hey, we don't want them using anybody else. We want to make all their money. The 200 OK, the text, and the number, which sometimes if it's a 47 or a 404, some ISPs will give you the exact reason, which is why he has both fields. Then you have the RTP address. So in our case, we're using open SIPs in the middle, so you'll have the box where the RTP is coming from, the endpoint, as well as above we have for called IP, the proxy. We then have the SIP call ID, which is important to us. As Voip Monitor will go ahead and it could store every single call in its own PCAP. Who here looks at calls in Wireshark? A raise of hands. Almost everybody. Okay. So instead of, in the old days, before we had Voip Monitor, what we would have to do is we'd have to go ahead, tell the customer, run TCP dump across the entire network, tell them to make their call, pull out the PCAP, hopefully find their specific calls, try to extract it, look at the call to the carrier, and it was a 2-3 hour ordeal till we figured out what went on. And we're also reproducing the issue later on. So if, say, BT had a problem, and now the problem went away, we don't even have a way of telling them there's a problem because no ITSP is going to claim responsibility unless you show them a PCAP and exactly what they're doing wrong. All the networks are perfect. They never have any downtime. So you really have to show them. So the great thing about Voip Monitor is that it saves every single call. So when you have a problem, so long as you have a call sample, you could pull that specific call sample. You don't need to go ahead and try to reproduce it. And none of us want to tell the customer, well, you're not having the problem right now, so everything must be okay. Reboot your router. We then have the user agent. I think this is a bug in Voip Monitor because it's only showing the Polycom, it's not showing Asterisk. We have the jitter, and then you'll have fields that start with A and B. A is the first leg, that's the phone sending the call to the PBX, and B is the second leg, the PBX coming back. And then the last thing we have is last RTP from end, which I'll go over in a bit. So what this does is this tells us how many packets are dropped in a row. So if it's A_SL1, if I had 2 individual packets that dropped, not good, but say out of 1,000 packets, it's really not the end of the world. The phone call will be good. If on the other hand, I have, on the bottom we don't have any of this call was okay, ASL10, where I have 10 packets in a row that drop, that phone call is going to be horrible. Even if that happens only once, it's still going to kill the quality of my call. Like I said, the last RTP from end, that's important to us because we have set up in our Asterisk boxes that if we don't get RTP for more than 10 seconds, we assume you disappeared, you fell off the web, and we're going to disconnect the call. So we could write a script that will then go ahead and find all calls where we have last RTP from end is more than 10 seconds, and the hang up. Did I put that over here? I think it's good, yeah, who hung up the call. In my case, I was just doing an example for Voip Monitor, so I hung up the call. But if Asterisk hung up the call and it's more than 10 seconds, of no RTP, then obviously we have a problem. The last thing we have over here, like I said earlier, is the reverse. For the developers here, the reason why we have it in reverse is we know an index goes from left to right. So if a customer tells me they called 1, 2, 3, 4, 5, 6, 7, 8, 9, and I go ahead and I put in % 2, 3, 4, 5, 6, I'm looking for the last few numbers called, it's not going to use the index. It's going to have to go over all the rows. It's going to take forever. The reason why we requested this feature is a lot of times we'll have customers that tell us, I dialed 1, 2, 3, 4, 5, 6, and the call is not working. We then go ahead, we look for 1, 2, 3, 4, 5, 6 in the system. There's no such call because the user dialed 1, 2, 4, 5, 6, dropped a 3, and it's my fault. So we wanted to be able to go ahead and search based on the last few digits and then show the customer you dialed incorrectly. The reason why we actually had this is when you call, for instance, in the UK, if you're calling a mobile number locally, you're going to be dialing 07 and then the number. If you're calling from international, it would be +447. We have call centers overseas where people only know how to dial by them. The customer says my number is 07, et cetera, et cetera. They then go ahead and dial +4407 and complain that it doesn't work. It got so bad that we played a message that if it's country code +0, where the country should not accept the 0 from out of the country, we played a message saying, you're dialing wrong, drop the 0, and then we get support tickets telling us, it's telling me to drop a 0, but this is my customer's number, why isn't it working? So you can't make this stuff up. So that's very helpful. So now we see the second leg going out to the provider. Pretty much looks the same, except for the fact that the called number has a prefix that the carrier wanted, and the caller ID is our office number, which again I changed. It's going to be the office number, and it's going to be the caller ID that we're sending out, and we're using port 5061. Like I said, there's a lot more information that's in the database that's not here because I couldn't fit it on the screen. Real quickly, because I have other slides, you could look at the average success rate for a specific user. You could write scripts to look at, is it going above or beyond a certain amount? For this time period from 10 a.m. to 10:05 a.m. for this Wednesday, for a week ago, for 2 weeks ago, is this customer below, 25% below where they used to be? We could write scripts to look based on our carrier's IP addresses. Is Verizon having a problem? Is British Telecom having a problem? We could look based on the countries. We've had it where we had problems to Saudi Arabia. No matter who we were sending it to, there was a local fabric issue. Everybody was having problems. So we tell our customers, we're sorry, we have 5 different ISPs that we're sending, ISPs that we're sending calls through, and every single one of them is having a problem, which you're gonna have to wait for it to get resolved. So it's up to the imagination of what you can really pull. Like I said, these are just some of the fields, but you could really, really write a robust system and try to figure out. But wait, there's more. So, like I said, the sniffer is open source, the GUI is not. In my opinion, every single penny it's worth it. I'm gonna speed up a bit because I'm running late. Basically over here we could search for any parameter that you saw in the database. We could look for the calling number, the called number, any field where it has a drop down, we could put any information that we want to put in over there. I'm gonna run through it real quickly, but pretty much any parameter of the call, and if you put in a %, it'll obviously, the wildcard, IP addresses under the RTP tab, we could look for calls where there's more than a certain amount of jitter. I had a case yesterday where a customer's PBX got hacked and we wanted to figure out where the calls were coming from. So I simply went and searched by their username as opposed to their IP, and I got all the IPs of where the fraudsters were connecting from, and we were able to ban them in the firewall. This is what it looks like when you have a result. So it shows you all the call information. This is from the Voip Monitor website. You can see we have the call sample. You're actually able to listen to the call if you have your customer's permission. A graph of the call. I forgot to mention that Voip Monitor will store that as well. And you see the packet loss, the jitter, all the other wonderful information about the call. One more slide before you accuse me of making commission of this, which I'm not. I just really like the product. Is you can see the call. If you click on SIP graph, you can click on any single leg. It sort of a bit looks like Wireshark. I personally always use Wireshark. I don't think there's any substitute for it. My guys are lazy. They'll use the web interface, they'll click on it, they'll look at the call, and they'll see if they see a problem. One more window from Voip Monitor is they have a graphing system where, based on any statistics, any metrics in the database, you could pull reports. So for instance, there's a dashboard that you could have up in the bottom right. We have the PDD, we have the worst offenders, who's taking a long time for post-dial delay. Me personally, I like writing my own scripts, so I know about it and I'm able to fix it, as opposed to just seeing numbers and not paying attention who it is. You could also put in names. So instead of showing IPs, you have customer names, you have carrier names, and you see all the information. We have, I believe on the top right, is how many concurrent calls, how many attempts, and other statistics. Again, we have SIP codes in a graph. All right. Lastly, and I alluded to this in the beginning, we use Cacti and Nagios. Cacti is used, we use it for monthly reviews and postmortems. We'll go ahead and look and see if there's a problem. We're able to go back and look and see what went wrong. Nagios is used more to let us know if there's a problem. So we set it to alert us and let us know there's a problem. It should not be in the same physical location as your equipment, because if your service goes down, if your internet goes down, there goes your monitoring tool and you'll never know about it. So we have our equipment in 60 Hudson, and we have a VPS sitting in New Jersey, and sometimes the internet connectivity between the two locations is a problem. We get 1,000,001 alerts, but I'd rather that than have a problem and not know about it. The more you watch, the better. In my opinion, you can't watch enough, provided that you're not going to bog down your box. Monitor anything and everything, whatever you could dream up of monitor. In our case, we monitor all the default stuff, and then each time we have a problem, we'll add it to watch that as well. We live and learn from every example, every problem that we had. Make sure we review it. Don't let the logs just sit there, and then when there's a problem, look over Cacti at least once a month. So if there's something that's odd, if there's something that doesn't look right, you know about it now, again, as opposed to using your customers as a monitoring solution. We have one customer that sometimes beats the monitoring solution because he's constantly hitting that redial button trying to find the problem and get a credit on his bill. What we watch in Nagios, we watch in Cacti. Like I said, Nagios is made to alert us. Cacti is made for historical data. So all Linux operating systems have the basics that we can watch over SNMP. Let me finish up real quickly. CPU usage, fan speeds, the load average on the box, the bandwidth usage, voltage, disk usage, uptime, temperature, the memory. We monitor on the entire box and per process. Other things that we monitor, how many users are logged onto the server. Is there too many people logged on, too many cooks spoiling the soup? How many open files are on the system? Is Asterisk limited by default in Red Hat to 1,024 files open at once, and that will severely limit how many calls you could have? What's the ping time to the server? Is the server acting sluggish? How about the CPU usage of every single process? So if there is a problem, we know Asterisk is acting up, we know MySQL is acting up, we know before the problem happens, but if the problem happens and it goes overboard and the box crashes, what do we need to look at why it went down? IO8, Asterisk hates IO8, well, Linux boxes in general hate IO8. How many calls are there? How many G729 licenses we're using, Asterisk calls, channels, how many users are registered is a very good indicator. If there's a problem with the connectivity to your data center and all of a sudden you normally have 1,000 people registered and all of a sudden now you only have 400, that may not be your problem, but it's somebody's problem, and customers don't care who to blame, they just want it to work. Outgoing calls, incoming calls, internal calls, how many Asterisk threads, et cetera, memory, like I said, memory usage by each process, logging or knowing if Asterisk is up or down, how many people are connected to MySQL. Is there some kind of problem where a script is hanging and it just keeps on connecting over and over and over, and then all of a sudden your MySQL system is unreachable? Are there any slow queries? Is anything bogging down the system too much? Is there any latency to carriers? So what you check and how you check it is all based on obviously the fan speed, the basics on the box, how much disk usage, voltage. That stuff you can find out from the manufacturer. But for everything else, what's normal for your system? Because even if the box could handle 1,000 phone calls, if your average is 250 and now you're at 350, there's probably something wrong. There's something interesting is going on. So you want to check it and you want to just make sure that everything is okay. Lastly, a 24/7 NOC. We have a US-based company. The company that we use is called Amoeba Networks. Plugging them because we like them a lot. They work very well for us. Again, getting nothing out of it. They watch our systems 24/7. It's a lot cheaper. It's about $200 a box. It's eyes and ears the entire time on your network 24/7. I know I sleep better at night knowing that if there's a problem, these guys know the basics of what to fix. We give them guidelines. If the box reaches 60% of the disk, watch it. If it hits 70% disk usage, here's a list of numbers of engineers, and you keep like a robot calling over and over and over and over and over until you reach one of us. We acknowledge there's a problem, and we go ahead and we fix it. We also have them doing small little scripts. Like I said, we had a problem where all of a sudden Asterisk ran out of RTP, so they quickly went ahead and generated a script to watch that at no cost to us. They're watching your network. It does not replace your core team because obviously you have your engineers that know what's going on. They're there to sit and watch. And like I said, if you have 5 boxes and it's costing you $1,000 a month, and once you leave the office at 5 p.m., you're not sitting there constantly with your phone looking and making sure your network is running, you know that there's a problem, they'll call you, they'll let you know there's a problem. And for us, for the few $1,000s that we pay to have this, it's invaluable. We also use them in cases of fraud. We have fraud prevention algorithms, and if they see fraud going on, they'll instantly shut it down. So yesterday I was actually here, like I mentioned earlier, we had a customer that compromised, and within a few minutes of the system alerting it, they shut down the customer. And one more last note, that they have experience, like these guys, because of us, know Asterisk, they know OpenSIPs, they know the basics to watch, and then if there's a problem, they will obviously investigate it and they'll help us look into it, and that frees me up to do what I normally do day to day and not have to bang my head if I don't have to. Any questions? Nope? All right, I think I finished just on time. Thank you very much.